In this section, we're going to talk about generally polygons. We already know about triangles. We already know about quadrilaterals. So now we're just going to take a global look at polygons. And what is a polygon? A polygon is a closed figure formed by 3 or more line segments called sides. Now, we already know that when you have 3 sides, the polygon name is a triangle. And we already know 4 sides is quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. And 10 sides is a decagon. And these you just have to memorize. So you need to spend some time making sure, because I'm not going to help you out on these, but if I ask you for a 10-sided figure, you need to know it's a decagon and so on. You probably already know these. This is just kind of a refresher for you. All right, now we're going to look at the sum of the interior angle measurements. We already know that a triangle has 3 sides, and there's 1 triangle in this 3-sided figure, and so the sum of the angles is 180 degrees. Now, here's what I want you to look at. The sum of the degrees of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. So, complete the chart and look for a pattern. So, 4 sides. Here's what I'm going to do. I'm going to take 1 angle and I'm going to draw a diagonal. Okay? And when I do that, it makes 2 triangles, and there are 360 degrees. Now in a pentagon, I'm going to take 1 angle, and I'm not going to draw a line there because you already have one. So I'm going to draw a diagonal here, and I'm going to draw a diagonal here, and then of course I'm not going to draw one there because that's already a side. So when I draw my diagonals, 5 sides, it created 3 triangles, and 3 times 180 is 540 degrees. So the sum of those measures is 540. So watch how I'm going to do a hexagon, 6-sided figure. I'm going to go from the diagonal. I'm not going to include it here. I'm going to go to the diagonal. I'm taking the same angle, and I'm going to the opposite angle again. And of course, I'm not going to do it here because that's already included in my sides. So I have a 6-sided figure, and how many triangles? I have 1, 2, 3, 4. And so 4 times 180 gives me 720 degrees. Now, I'm not going to sit there and draw a 20-sided polygon and figure out how many triangles are in a 20-sided polygon. So there comes then how there has to be a formula of how I do it. So if n represents the number of sides, then the sum of the interior angles can be used finding the formula. Look what we did. How did we go from 6 to 4? How did we go to 5 to 3? 4 to 2 and 3 to 1. What did we do? We took the number of sides and we subtracted 2 from it. That's what we did. And then we found the number of triangles, and then we multiplied it by 180. So the sum of interior angles can be found by taking the number of sides, subtracting 2, timesing by 180. Why would we subtract 2? Because look, I didn't include, let me do that in a different color. I'm subtracting 2 because I didn't include this side and I didn't include that side. So 6 minus 2 sides. Same thing in a pentagon. I didn't include this side and I didn't include this side in my diagonals. So that's why I'm subtracting 2. 5 sides minus 2 gives me 3. And so on. So you're subtracting 2 because you're not including the sides of that polygon. So there's my formula. So how would I use this? Well, a heptagon, we know a heptagon is 7 sides. So the sum is going to be 7 minus 2 times 180, which is 5 times 180, which is 900 degrees. Okay? Well, a 25-agon. I'm not going to draw a 25. sided figure. So what am I going to do? I'm going to take 25, subtract 2, and times it by 180. So that's 23 times 180. And I'm going to look at my answer key because I'm not going to do that in my head. And I get 4,140 degrees is the sum of the interior angles there. Okay, so that's how you use the formula. Let's go to the next page and take a look about this congruency statement. All right. Congruent polygons. What are congruent polygons? They have the same angles and sides. Okay, so they have the same, they have the same size, what am I doing? And shape. Same size and shape. And all corresponding parts, sides, and angles are equal. Okay, so they're going to be the same in both of those. And they're equal, also called congruent. The measurements are equal, but they are congruent. So if you look at this, this is called a congruency statement. I call this my Big Daddy statement because there is so much power in just what this suggests. I don't even need to draw a figure because there is so much information. It is in the same order. So I could, just by looking at this picture, I can say that angle A is congruent to angle D. I can say that angle B is congruent to angle E, and angle C is congruent to angle F, just because of the order. Now, this is what my picture would look like. Remember, A and D have one marking, so those are congruent, but look, same order. B and E, congruent, and then the same order. And C and F are in the same order, and these guys are congruent. Not only does this congruency statement tell you about the angles, but it also, if you look at the order, tells you the sides. I can say that AB, just because of this placement of the AB, I can say AB is congruent to DE. I can say BC is congruent to EF. And I can say that AC is congruent to DF. So there is so much power in this one congruency statement. I have 6 statements that I can make, 3 on angles, 3 on sides, just from this one statement. That's very, very powerful. I don't even need a picture, although a picture certainly helps. So a valid congruency statement must match all corresponding angles and sides. So let's take a look at number 5. Because I am making this statement, triangle WXY is congruent to triangle QRS, angle W is going to be congruent to angle Q because it's in the same order. Angle X is congruent to angle R, angle Y is congruent to angle S, sides WX is going to be congruent to QR, sides XY is going to be congruent to RS, and sides WY are going to be congruent to QS. All because of that one statement. Big Daddy statement. So rhombus, same thing. Even though it has 4, I still have 4 congruent angles and 4 congruent sides. So angle E is congruent to angle J. Angle L is congruent to angle G. Angle H is congruent to angle M. EF is congruent to JK. JM is congruent to EH. And GH is congruent to LM. So that is my Big Daddy statement, congruency statements. All right, now how do we use algebra for that? Well, it's the same thing. Looking at this picture, I know that angle R is 129 degrees, so I know that angle V is going to be 129 degrees. I know that angle U is 21 degrees, so I know that angle Q is 21 degrees. Can I find this third angle measurement? Of course I can. It's a triangle. How many degrees are in a triangle? 180. So is that what the question's asking though? Do I need to find? I don't even need to find European. That's fantastic. So I know that angle Q is 21 degrees. I know that angle V is 129 degrees. Angle P, I do need to know angle P. So it's going to be 180. Minus 21 and 29, which is 150, so angle P is going to be 30 degrees. PQ is similar to TU, and TU is 21 feet, so I know that PQ is going to be 21 feet. Make sure you have the unit measurements in there. And RQ is going to be congruent to UV, which is 13 feet. So UV is 13 feet. So that's how you figured that out. Same thing with a quadrilateral and a trapezoid. Let's look at the trapezoid. That one just looks kind of fun. So I know that M is congruent to M. Angle O is congruent to A. So if A is 125, O is 125. I know that H is congruent to E, so 72 and 72. And I know that I can find vertical angles here, so 108 degrees. So I know I can find that fourth one because there are 360 degrees in a quadrilateral. So I know that if I add them up, angle T is going to be 55 degrees. 125 plus 108 plus 72 minus 360 is going to give me 55. Now let's look at the MA is congruent to MO, so that's going to be 11 meters. I know that MH is 9, so ME is 9 meters. I know that RO is 15, so AT is 15. And I know that RE is 23, so I know that TH is 23 meters. And then I can, of course, plug these in. So angle E is going to be 72 degrees. Angle T is 55 degrees. Angle O is 125 degrees. Psi EM is going to be equal to 9 meters. And HT is going to be 23 meters. So that's how we fill those Big Daddy congruency statements in. If that's confusing, come see me.